our planet may be under threat. One day, a natural or man-made disaster could make life on Earth impossible. If we can't live here, where will we go? Meet Dr. Basil Singer, physicist and robot builder. He's on a mission to find a new home for the human race.
Imagine doing this with a spacesuit on.
He'll use the best science on Earth to work out where in space we could live and what dangers and adventures lie ahead for the space pioneers.
The third stage completely pressurized. Ignition.
6 pioneers brace as the space plane is released.
2, engine ignition, and liftoff.
It cuts through the upper atmosphere at Mach 6. Ahead, the mothership that will take the crew 350 million miles to the moons of Jupiter.
Command coming in now.
My mission is to plan the human colonization of Jupiter's moons. Jupiter itself doesn't have a solid surface. It's made of gas, but its moons are rocky like the Earth, and some are as big as planets. I've been checking out rockets that will take us to Jupiter in express time. I've seen technologies that will allow us to survive and flourish in extreme conditions, and I've experienced the thrills and spills our pioneers will face on these extraordinary moons. This is a mission to Jupiter's moons, a mission to save mankind.
Callisto and the Jupiter system are just a mini solar system waiting to be reborn.
Europa offers one of the best prospects for finding life in our own solar system.
We will protect the Earth as a national park where humans will always come back to find their roots, but that will not be their home. Their home will be somewhere else.
This is my data command center, where I'm compiling all the information I need to plan the mission. Jupiter has 62 moons, but most of them are just a few miles wide, and that's way too small to set up home there. The exceptions are 4 moons so big that you can see them from Earth with binoculars. Callisto, Ganymede, Europa, and Io. To work out which one to send the pioneers to, I need to take a much closer look. The very best data has been collected by space probes, so I went to see an imaging scientist from the Galileo mission, Clark Chapman.
Of the 4 moons of Jupiter, Callisto is the farthest away from Jupiter, and it's the darkest in color, but it also has bright white exposures of ice on it.
The whole of Callisto is a mush of rock and water ice, and it's almost entirely covered in impact craters. Its ice will be a great resource for the pioneers to live off, but the craters will make it hard to explore. Perhaps the next moon in, Ganymede, will be better.
Some areas are very ancient geologically and heavily cratered. There are other places in Ganymede that are geologically more recent.
These younger areas are smooth, icy plains formed by the action of volcanoes which spewed water, not lava. This would be a much easier environment to explore than Callisto. Ganymede is also the biggest of the moons, so the gravity will be closer to what we're used to on Earth. Next in line from Ganymede is Europa, and it's got to be one of the strangest places I've ever seen.
Europa's surface is covered with ice, and it has very few craters on it. It doesn't look like many of the planets and satellites in the solar system. It has grooves.
These grooves are thought to be where Europa's frozen shell has cracked and filled with fresh ice from below. The surface is 6 miles thick and hides something truly remarkable: a warm ocean of liquid water 60 miles deep.
Europa is warmed by the tidal forces from Jupiter and probably has subterranean volcanoes, perhaps, like we have under the oceans on the Earth. It's a fascinating place, but so far we've only seen its surface.
The closest moon to Jupiter is Io. Jupiter's gravity distorts it, creating heat from friction, which in turn results in active volcanoes on the surface, spewing sulfurous gas into space. Unlike the other moons, it's completely water-free. Water is an essential pioneer resource, so I'm going to reject Io as a target for colonization. But the icy moons of Callisto, Ganymede and Europa are all still contenders. Before I decide which of these ice worlds to go for, I need to work out how to get to Jupiter. Journey time is the biggest consideration because it could take years. Being in space for that long is seriously bad news because without gravity, muscles waste and bones thin. To help combat these effects, astronauts exercise in space. By pulling their bodies to treadmills with elastic ropes, they can simulate some of the gravity that's felt on Earth. The ultimate aim is to create a system that mimics gravity. And that's what's being developed here.
Can I get your... Okay. Yes.
It may look like a puppeteer's workshop, but these cables are used to recreate what it's like to exercise in space.
We've got his upper arm and lower arm supported, and his upper and lower legs. And his torso and his head are supported by this cradle and helmet. So in this way, we're basically orienting him horizontally.
Gail Perusek studies how much and how hard astronauts in space need to exercise to stay healthy.
When we're on Earth, we are in 1G all day long. And so can we replace all of that day's worth of loading with a discrete exercise session and still maintain health? What's the max for Marius?
156.
156.
The vertical cables are there to recreate the feeling of weightlessness in the lab. But this pair of horizontal cables and the harness they're attached to are Gail's real concern. Currently, astronauts rarely exercise above 65% of Earth's gravity. But Gail's setup turns that up to 100.
One of the things that's preventing that from happening now on orbit is the comfort of the harness. So we've run consistently with 100% body weight with no problems with this harness design.
Getting exercise right is a huge issue because the low gravity of space does some surprisingly serious damage to your body.
In microgravity, there's hardly a system in the body that's not affected. The bone loss that occurs begins to happen very rapidly. Calcium is absorbed, and the rates of bone loss that we see in crew members are about 10 times that of a postmenopausal woman.
Russian cosmonaut Valery Polyakov spent 14 months in space, the longest that any human has spent in microgravity. He was a physical wreck when he returned to Earth. But it's not just your legs and bones that weaken. Without gravity, the heart gets weaker too, as it's easier for it to push blood around the body. So Gail keeps the workouts hard.
Okay, so we got another 30 seconds. 30 seconds. Good job. Because of the duration of the mission, I would definitely recommend sending exercise equipment along. I would say that crew health is, it's certainly paramount, and exercise and exercise countermeasures are right up there on the priority list.
Exercise is one solution to getting to Callisto in good health. Of course, the alternative is to get the crew there much faster than current technology allows. It's something that astronaut Franklin Chang Diaz has been working on for 30 years. That's a really good photo of existing rocket technology. Can you see this technology getting us to places like Jupiter?
Not really. We will need advanced rockets. This is what we're working on here. Plasma propulsion.
Franklin's invention is called Vasimir. Instead of burning rocket fuel, it heats hydrogen gas until it turns into the fourth state of matter, plasma. Plasma is the same stuff that the Sun is made of, and it has the potential to take us to Mars in a month and to Jupiter in less than a year. What you're looking at is a jet of plasma at 1 million degrees Fahrenheit. And it needs some serious equipment to keep it contained. That is a massive door.
It is pretty massive.
Must be about 3 tons or something.
And if you push it very gently, it just itself goes, you see?
Wow.
Now this is a lot like being in space. You see what it takes to slow things
still got
down.
a lot of momentum, hasn't
Yeah.
it? And there's the Vasimir engine.
There is the engine.
Although it looks small, this is a full-sized prototype, and Franklin believes I'll only need 3 to get my crew to Jupiter. How do you make the gas into a plasma?
The gas is ionized. It's turned into plasma by the action of radio waves. Very much the same way you heat things in your microwave oven at home.
The energy of the radio waves is absorbed by the hydrogen atoms, heating them to a plasma, which is then channeled and accelerated out of the back of the engine by magnets.
The gas comes at one end and it's turned into plasma, accelerated and ejected out into the chamber, and that's what produces the rocket thrust.
This engine is great news for space travelers, but there's a drawback. The magnets are currently made of copper, far too heavy for flight. The solution is lightweight, superconducting magnets, but they only function when they're cold. Jacob Chancery showed me how these curious black discs work.
Right now this is not working as a superconductor because it's at room temperature. You can see that it doesn't repel magnetic fields.
Jacob's magnet only starts working at -300 Fahrenheit, the same temperature as this stuff, liquid nitrogen.
Let's see if it'll work now.
There we go.
There we go. If I blow across the top of this cube with a straw, you can see that little cube will start spinning so fast, you can't even tell it's a cube anymore.
That is very cool. In the same way they levitate the cube, a coil of these magnets inside the engine will work like an invisible nozzle, controlling the flow of plasma without ever touching it. And you have to keep your magnets within this motor at these temperatures.
That's right.
Well, at the same time, you have to keep the plasma at incredibly high temperatures.
That's correct. We have a lot of very high-tech insulation to be done between those two elements.
Yeah. Jacob has his work cut out because Vasimir is going to be in space sooner than expected. Whilst I was playing with magnets, Franklin received a contract from NASA to test his engine aboard the International Space Station. I really like today, and the engine that we've seen today is absolutely amazing because at the moment it's using existing technologies. It's a combination of plasma physics, electromagnetism and RF physics, all combined to make this amazing engine. What I really like about it is that it's another step towards, you know, the warp drive of science fiction. Absolutely astounding.
The space plane and mothership align for docking. But the walkway jams. The crew get changed. They're going to have to do this the hard way. Vazimir engines fire. As the Earth shrinks behind them, the crew raise a drink to their new life and the adventures that lie ahead.
This mission is headed out towards the giant gas planet Jupiter. I have to choose one of its moons to set up a human colony. I've got my shortlist down to 3. The ice worlds of Europa, Ganymede and Callisto. Amazingly, I managed to find somebody else who was faced with a very similar problem.
I would worry that would impact this, so the other option could be you could have just the cable floating with it.
Pat Troutman is head of NASA's Advanced Concepts Lab, a group who use Hollywood-style CGI to dream up future space missions. He was asked to find the perfect moon for a base to explore Jupiter from.
There's such a large distance between Earth and the Moon, from Moon to Mars, and then another quantum increase from Mars to Jupiter, that you need an outpost in the Jovian system just to explore the whole system. And that outpost is a place you can go back. It has safe haven, it has supplies, and a basic infrastructure so that you can recoup from your battles with the wilds.
This outpost needed to be constructed somewhere close enough to study Jupiter in great detail, and have enough resources to fuel further missions to the outer solar system.
We can't go to Jupiter itself because the gravity would just crush and there's no real surface on it. When you start looking at the moons, of course Europa is very interesting. It has oceans, we think, under there, but the radiation environment is so severe because it's so close to Jupiter that we really couldn't fathom going there.
Jupiter has a massive magnetic field that traps passing radiation, forming an invisible but deadly belt that extends into space. Europa is in the thick of this band. A human landing there would be dead within a day. So that's another moon off the list, leaving just 2.
So we start backing out and looking at the other moons, the major ice moons, Ganymede and Callisto, and both were good candidates for going there.
Ganymede, the next moon out, suffers less radiation. But there's one moon that escapes Jupiter's band altogether, Callisto.
So it was a sweet spot, so to speak. And again, being covered with ice is just the best material we could possibly have. Callisto is just a fantastic place to go.
It may not be as smooth or as large as Ganymede, but Callisto is my choice. It's big enough to make a home there, it's got plenty of water ice, and it's outside Jupiter's deadly radiation belt. But what would it be like to live there? Well, for a start, it's much smaller than the Earth, about 1/3 the size. That means it has less gravity too. Coping with this will be one of the biggest challenges the pioneers will face. So I decided to experience it for myself in the most amazing laboratory I've ever been to.
Whoa. Thanks.
Certainly.
Wow.
This is our reduced gravity laboratory. It just happens to be inside an aircraft.
That just looks like a commercial plane.
Well, it is very similar. It's actually a military version of a DC-9. It's a C-9, and it's been refurbished by NASA to perform the reduced gravity mission. We'll pitch up at anywhere from 45 to 52 degrees nose high, go over the top after about 8,000 feet, pitch back over, and free fall back down. And we'll go right into the next one, maintaining that energy. And by varying that parabolic flight profile, we can actually vary the G field that you will feel inside the aircraft.
So just by tuning the pitch and the throttle, you can simulate the moon's conditions, you can simulate the Mars conditions, any kind of gravity you want.
Whatever your research requires, we can adjust our flight profile and provide that for you.
The smooth curve of the flight path is called a parabola. It's the same curve that roller coaster tracks make, and it ensures that the level of reduced gravity is the same on the way up as it is on the way down. Test director Dom Del Rosso has scheduled a few parabolas at Callisto gravity for me today. It's a real honour, as it's very rare for visitors to be allowed inside this incredible flying laboratory.
So there's one last thing we need to do to make sure you're fully kitted out here, is we need to make sure that you're properly identified for the flight today.
My own name badge.
Outstanding. Well, welcome aboard.
Thank you very much.
It'll be an outstanding flight.
Before the flight, I had to go through a briefing.
Obviously, you may not feel well, you just might feel strange. If you do need to go back to the bathroom for any reason, please let one of us know that you're going back there, because we don't want to be flying parabolas while you're in the bathroom unannounced.
And take a little something to help the nausea that I was assured would be coming my way. What I was letting myself in for was a stomach-churning 60 parabolas in total, over 3 hours flight, but only a couple of minutes at Callisto gravity.
So excited about it, it's been amazing.
The rest of the time was for these guys, a huge team of engineers and astronauts testing out prototype suits for the 2020 moon mission. Once we were safely out over the Gulf of Mexico, it was time for my first taste of reduced gravity.
Sure. Whoa! We're at 0.3G, 0.2G. I'm feeling so light.
Yeah.
Wow!
This is close to Mars gravity, and it's what the astronauts needed for the first part of their testing.
That is so good.
For every 30 seconds or so of reduced gravity, you have about 15 seconds of increased gravity to endure at the bottom of the parabola.
Right, we're getting heavy again. That's really quite heavy.
The meter on the right shows the level of G, and here at 1.8 G, my body weighs nearly twice as much as usual. The astronauts needed 17 parabolas at 0.2 G for the first part of their testing. But on the 18th, I was allowed to experience what I'd come for. Callisto gravity.
Wow! Absolutely amazing! So this is 0.1 G, and we're simulating what it would be like on Callisto.
I discovered that on Callisto, it'll be very easy to juggle.
I've got so much time.
Ridiculously easy to climb.
So weird. You could scale up rock or ice incredibly easily.
And exercising would be a breeze. But having a drink of water after, surprisingly difficult.
It's definitely a very odd sensation, and the body is not used to this. I tell you what, it would take some getting used to. It's odd, very odd.
With my brief experience of Callisto gravity over, flight control was handed back to the astronauts to complete their testing. And I had to take a back seat for the remaining 2 hours of flight. I can certainly see why they call this the vomit comet. When they reach Callisto, the crew won't be able to land their mothership. It's too heavy to bring to the ground safely. Instead, they'll have to live in a base made by joining modules small enough to fit on a lightweight lander. Each time the lander returns, it brings back another module. The only problem with this plan is that the first hab to land has to contain everything the astronauts need to survive, and there's not a lot of room on the lander. It's a tough problem, but it's one that NASA is already looking at.
When we go to Callisto, we want to make sure that we can bring enough supplies that they can stay on the surface for 30 to 90 days and maybe go back and forth to the mothership to get more. But you have to bring those supplies to the surface.
But a hab full of supplies means no room for people. Pat's solution is a module that inflates to create enough room for 6 astronauts, filled with the same air that the people inside will use to breathe.
So the great thing about an inflatable habitat is you can bring your stuff with you, you inflate it, now all your goods are inside of there, but now I can live around it. So what we're looking at for Callisto is a larger variation of what we're talking about here with this inflatable habitat.
Pat's work is to dream up concepts on a computer screen. John Dorsey turns those dreams into working hardware.
storage space, a place for a convection oven. Around this corner we have the workspace, some tools, some lunar rocks, some computers.
As well as providing living space, each module has to be self-sufficient, with systems for oxygen production, humidity control, and recycling water.
So it's a very challenging job to package all that stuff into the smallest volume, as well as give the astronauts the space they need and not go kind of stir crazy.
Once the Pioneers are settled on Callisto, they can fire up the lander and return to the orbiting mothership to pick up more modules. That's the theory, but it's not straightforward because it relies on having lots of rocket fuel. Fortunately, Callisto isn't short of the raw material you need to make rocket fuel on site: water.
Well, we used to think that the solar system was a very dry place, except for our own watery planet. But as we ventured out, we began to discover frozen ice, snow, frost, and there's lots of it.
The fuel that powers modern rockets is hydrogen, one of the two elements that water's made of. And Callisto is just a big dirty snowball, 50% H2O. Splitting water to make hydrogen is a surprisingly simple process. First, take some ordinary water. Add something to it to help it conduct electricity. Here I'm using salt. Make a pair of electrodes from metal, connect them to a power supply, and place them in the water. Add a container to collect the gas, switch on the power, and sit back. This is just a typical high school electrolysis experiment. What we're doing is we're passing a current through water and we're ripping apart the oxygen from the hydrogen, and what I'm collecting is the hydrogen part of that in this bottle, and that is going to be a really useful thing to do in space because hydrogen is a good fuel. When you're doing electrolysis, not only are you ripping the hydrogen out of water, but you're ripping out the oxygen as well, and you can use that for respiration. On Callisto, you do the chemistry with specialized equipment, avoiding the scum I'm getting here. You'd also use a small nuclear reactor to provide the heat and electricity, but the results would be the same: pure hydrogen gas. I've collected a small amount here, and to prove it, there we go. This simple reaction is fantastic news for people who are trying to colonize a different land, because this means that you can be completely self-sufficient. Pat's plan for a future base on Callisto is complete with machines to carry out these reactions automatically.
We have like mini bulldozers that are collecting the ice from the surface. They put it in these bins. The bins will then go through and crush it up and melt it. Then it becomes electrolyzed. We run a current through it and put it into hydrogen and oxygen, store it in big tanks. And the neat thing is I've got rocket fuel. I can go up and down the planets. I can have stuff to drink. I have stuff to breathe. It's just the perfect place for it.
Pat's dream is to have a completely self-sufficient outpost on Callisto, offering a spacious, comfortable environment for humans to live and thrive. And with the abundance of water on Callisto, the opportunity to make an interplanetary gas station for future generations to go beyond Jupiter to explore Saturn and the rest of the outer solar system.
Yeah, I think about it all the time. I think about looking up in the stars and seeing Jupiter and Saturn a little bit closer. And I often do it when I go home at night and it's a clear night. I look up and I see all these places that we can explore, that someday we will explore.
Two pioneers out exploring Callisto with a rocket hopper. But the engines won't start. They're out of gas, low on oxygen, and a long way from home. Two pioneers cut off from base. A mile-high wall of ice separates them from home. They break open the ropes and prepare for the longest climb of their lives.
I'm planning a mission to Jupiter's ice moon, Callisto. So far, I've discovered how humans could exist there in comfort and provide all of their own water, oxygen, and rocket fuel. But Callisto is no tropical paradise, and finding a way for the pioneers to explore their environment is going to be one of my biggest challenges.
The space pioneer on Callisto would want to dress very warmly because it's very cold outside. It gets as hot as minus 160 degrees Fahrenheit and then get down to minus 300.
The surface of Callisto is also almost completely covered in impact craters, which makes for a treacherous terrain.
Fascinating thing in front of you are these great cliffs, the sides of craters, maybe a mile or more high, patches of white exposed ice, and you'd like to climb up there to look around and see the wonderful terrain on this planet.
Providing my crew with the right tools to get around this vertical world is going to be essential. So, I found some Callisto terrain on Earth and checked out how the experts do it here.
Yeah, the surface of Callisto is all rock and ice. Just like this, it's perfect.
Well, you're gonna need to use crampons if you ever end up there.
The most important spikes on these crampons are the pair at the front, which stick out for support on vertical walls of ice.
You could never climb without tools, could you?
Well, on ice you couldn't. Rock climbing you don't need them, but since we're in Callisto, you're gonna need your crampons. You're gonna need your ice tools, ice screws, all those things.
It turns out that not all ice is the same.
Here we go, that is proper ice wall.
Yeah.
I was going to have to learn how to spot the formations that would take my weight.
Okay, now when you look at a field of ice to swing into, your first choice is going to be ice that's concave, like this or this. Your second choice is ice, I guess, that would be flat. And then your third choice is going to be ice that's convex or rounded like a ball.
Okay, yeah.
That surface tension there makes it more likely to pop off when you hit it.
You need high-tech gear to get you to Callisto, but a really simple tool will save your life when you're climbing its vertical ice walls. The ice screw.
You can actually ram it in there. And you can use two hands, you're just getting into it. There you go. And now just start trying to turn it until it bites down. There you go.
Really cool.
They'll hold over, several thousand pounds. It's a very reliable...
Several thousand
pounds. People take really long falls on them. You can make anchors out of them. You can just hang from them. That's super solid. Two ice screws like this could easily become a really strong anchor straight away.
Yeah.
Lesson over. It was time to try out the techniques I'd learned.
Yep, you're tied in.
From now on, I was on my own.
How high is this bit here?
I'd say about 45, 50 feet tall.
Yeah, that's a good one to start.
Oh yeah, definitely. Now really think about lifting the front of your feet when you kick it. Good. Perfect.
Although climbing ice is quite technical, it's a great surface to explore. If Callisto was made of rock, getting around would be far harder.
So when you get a good hold on the axe, you just know, it just feels right. The thing that worries me is not the pickaxes, it's your feet position. The crampons I haven't quite got used to yet. It takes a while to start to trust them.
The higher I got, the more I began to trust in the ice. Unless you've tried something like this, it's hard to imagine just how well it supports your weight. And on Callisto, it'll feel even more reassuring because the colder it is, the stronger ice gets. I may have got the skills, but it was starting to sap my energy reserves.
Imagine doing this with a spacesuit on. Man, that would be difficult.
But with only 10 feet to go, this wasn't the time to give up.
There we go. One more. That was close. Hey!
Good job. Well done.
Oh, that is unbelievably tiring. Getting used to the tools is one thing, but fighting against the gravity that we experience on Earth just pumps your muscles right up. But if you're on Callisto, where the gravity is only about 1/10 that it is on Earth, it's kind of like the moon's gravity, you could just scale up that with no problem at all. Fly up there. However, then you've got the added difficulty that you're wearing a spacesuit.
Spacesuits are designed to put pressure on the skin of astronauts. Without it, respiration would be impossible and their bodies would swell up, causing massive tissue damage. Traditional suits are blown up like balloons to provide this pressure.
Now we're going to take you up to 1 psi.
Okay.
And we're going to do some leak checks to make sure the suit's sealed up all right.
Right.
Okay?
Oh, pressure's going up. Swallowing. Clearing my ears.
I tried moving around in one and I can tell you, it's not the sort of thing you choose to go climbing in.
It's quite heavy on the shoulders. I feel like a bit of a robot, actually.
If the pioneers are going to negotiate Callisto's extreme landscape, they're going to need something a lot more flexible. And this could be the answer. It's a prototype called the biosuit. Instead of air, it uses tight material to put on the squeeze. And its inventor thinks it will be perfect for climbing on distant worlds.
The biosuit's design is very different than a conventional gas pressurized suit. The concept is mechanical counterpressure. So we're applying the pressure directly to the skin. And you can see Allie's wearing it and it gives her a lot of mobility.
Each suit will have to be custom made to the individual to ensure a perfect fit.
We take 3D laser scans of the person in moving around in all kinds of positions, and then we're really selecting the materials and we design the suit so that it completely follows the movement.
This suit would be perfect for getting around Callisto easily, but climbing is a rough business.
If you get a small tear, just basically put on a bandage of the same type of materials and you could just go about your business.
The design of the suit will even help to counter the extreme temperatures that the pioneers will face on Callisto.
We can do some thermal conditioning in terms of, again, through the smart wires. Is she hot? Is she cold? We would like to heat her up, cool her off just a little bit. But you would also have additional layers on the top for real thermal control, just like when we explore Antarctica.
I'd imagined that scaling Callisto's peaks would be impossible in a spacesuit. But this fantastic design would make climbing a breeze. And more than that, it would truly open Callisto up to exploration. The biggest danger facing pioneers on Callisto will be radiation sickness. Although they're outside Jupiter's radiation belt, there's still the slow drip of cosmic and solar radiation to worry about. If they spend too long away from base, they'll have to build shelters to avoid overexposure to this cumulative threat. But what should they build them from? I asked an expert who's been doing radiation research since the Apollo mission.
We have an americium beryllium radioactive source which produces neutrons.
Neutron radiation is particularly dangerous because it passes through most materials easily and does terrible damage to human tissue.
More clicks means more radiation, fewer clicks means less radiation.
This setup produces a similar radiation environment to the one you'd find on Callisto. Let's see how well NASA's latest shielding material works. It has a high hydrogen content, and it's the hydrogen atoms that are supposed to absorb the energy of the neutrons. Not bad. It cuts the radiation by half.
You can machine it and cast it, but it serves no other purpose, and it weighs, a significant amount when you start shielding the entire spacecraft. You're paying to launch shielding.
The pioneers couldn't possibly carry tons of shielding with them, so I asked Sheila to try out something local to Callisto.
We have some ice here. This is just plain old ice out of the refrigerator.
The hydrogen atoms inside the ice absorb the radiation energy. And surprisingly, they do it just as well as the high-tech plastic.
You can take advantage of the ice with natural structures, say burrowing into a thick cliff. You could very well build a very feasible indigenous shield without having to pay to launch it.
The results of this experiment are significant. If radiation shelters can be easily made from local materials, then Callisto really is a place that we could build a new human civilization.
Radiation meters flash. The pioneers have reached their daily limit. A natural tunnel, but a section breaks free, and the lead climber falls. A pioneer falls. Reduced gravity and an outstretched hand save him. He's thankful for his new home. On Earth, the fall would have killed him.
Having collected all the data, I'm convinced that Callisto is somewhere that we could live in the short term. But is it somewhere that generations of humans could thrive? I've seen how ice could protect the pioneers from radiation, but I wonder if ice could also be the key to long-term housing.
The surface is just rock solid. So if it's geologically stable, we can dig tunnels, we can burrow, and again, with nuclear power and heat, we can do all that.
With airlocks on the front and compressed air inside, pioneers could live in homes made from ice, like the guests at this ice hotel in Sweden.
Anyone who's dealt with making a snowman knows you just have to melt it and shape it a little bit and stuff like that. And you could have all sorts of chambers and rooms going off. The surface is so stable that you don't have to worry about it caving in on you.
And with a system of homes that can be so easily expanded, Callisto offers the potential to house a lot of people.
Basically, you have everything you need for life. You got heat, you got energy, you got water. We can live there.
Callisto is a great target for colonization, but its low gravity and potential for creating huge supplies of rocket fuel also make it an ideal base for exploring the other moons of Jupiter. And the first one I'd want to check out is Europa, with its weird cracked surface and warm liquid ocean. As it's so far from the sun, you'd expect Europa's water to be frozen solid. But Jupiter's gravity distorts the moon, warming its rocky core, which melts the ice above it and forms undersea volcanoes. Although it looks like nothing else in the solar system, there's another reason why scientists are fascinated by it. Because its ice crust may hide an amazing secret.
Europa offers one of the best prospects for finding life in our own solar system because of the liquid water and the conditions possibly within that ocean.
Charles Coquelle looks for life in volcanic rock, found in the icy waters under glaciers on Earth. He believes that the rocks found in these remote places and the conditions they're exposed to are very similar to the rocks that lie on the seabeds of Europa.
So this rock we're looking at here is about 1 million years old, and it comes from underneath a glacier in Iceland. It's a very reactive material that makes a very good supply of nutrients and food for microbes. And inside this we find microbes making a living.
Extremophile bugs like these thrive in freezing cold, dark water, living off nothing more than the minerals in rocks. And since our solar system is made up of pretty much the same stuff, it means that the rocks formed in these volcanoes on Earth should be the same as rock produced by volcanoes on Europa. And if bugs can live here, why shouldn't they exist there too?
The raw material of planets themselves is a source of food for life. If microbes can eat elements out of rocks, and these elements are universal, found right the way across the universe, the question is, could there be similar types of life forms elsewhere eating rocks as we observe on the Earth?
Unfortunately, finding life on Europa is not going to be straightforward. It's much closer into Jupiter than Callisto, and feels the full force of the radiation band that surrounds the planet.
Because of the intense radiation on the surface, I wouldn't suggest sending humans there, but the potential for actually sending a robotic probe there, drilling through and investigating the ocean looking for signs of life is very intriguing. You could operate the robot on Europa from a crewed base on Callisto and actually go do that science and look for life there.
If we find life in the seas of Europa and prove it evolved there independently, it will fundamentally shift the way that we view the universe. Because water, rocks and volcanoes are everywhere, and life may well be too. The mission to colonize Callisto has been a wild ride.
Wow! Absolutely amazing! This is such good fun.
I've discovered that the technology to get us there is within reach.
That is very cool.
And the hardware to live, thrive, and survive is already being developed. Callisto may be far away, but it could provide a safe sanctuary for mankind. And more than that, its proximity to Europa means that setting up home there could help us answer the greatest question of them all. Are we alone in the universe?